So we are going to be talking about conservation of mass in different parts of a chemical reaction today, and eventually we are going to also be talking about how to balance chemical reactions today. Hi? It's a whole blank sheet?
There's something called turn the page. I don't know if you ever heard that.
Is it, you got it?
You didn't have to finish
We good?
that statement.
All right. Now, so guys, so moving on. In a chemical reaction, this is where you probably need to write a couple of things down. In a chemical reaction, the number of atoms of each element must be the same before and after the chemical reaction, but they do not have to be in the same order or combine the same. So looking at this particular reaction that we were looking at, that's presented with us, we have hydrogen and nitrogen on one side, and I'm telling you that there are a total of 6 hydrogens and 2 nitrogens on the left side, and on the product side there are 6 hydrogens and 2 nitrogens, and I'm going to teach you how to identify that in a second. So questions about that? Do we have that written down? Can I move on? Okay, so
Everybody else got it?
Yeah.
do I need to go back?
Yes.
So in a chemical reaction, like I said, this is like on paper, okay? We good? In a lab, we can observe chemical reactions, and like the lab that we did the other day was the baking soda and vinegar lab, and here's a demonstration of a very, very similar lab. It's just a different twist, in which case there was a balloon. So in the beginning, so these would be the reactants. This would be the starting materials. And these would be the ending materials. So the issue is that in a lab, the mass of the reactants or the starting materials, the things that we start with, has to equal the mass of the products. So this picture is demonstrating the fact that we are going to collect all of the products, and one of the products would be a gas, and we observed that yesterday when we were mixing the vinegar and the baking soda. There's a gas being produced, right?
So you said in the lab the mass of the reactants. You had another term for reactants?
Materials.
The materials?
Those starting materials.
Starting materials?
Okay. And the ending materials. And we are going to go ahead and get some vocabulary today. Good times,
When
right?
are we going to do a lab with the balloon?
I don't know
Why?
why. Well, I don't know. Anyway, moving on. So in the kitchen, and we did talk about this a little bit the other day. What? The mass of the popcorn kernel doesn't change as it goes through a chemical reaction of popping, but you can measure the release in steam as well. So the mass so the kernel may not change its mass, but there's steam being produced, and as a result of that, there is this chance that we could see a change in mass. Yes, sir. What's right there? What does it say?
It says a bag of popcorn has a mass that is slightly less than the unpopped bag of popcorn because of a small amount of steam is released. If the steam was captured, the mass would remain the
Same. The answer would be the same.
Well,
So in that blank, put the same. Okay. We good? Did you get that? All right, next. Here is an example of a chemical reaction, and we're going to use this chemical reaction throughout the course of the next few slides to kind of illustrate a couple of things. The first of things that we are going to illustrate is the chemical formulas. So like, for example, CH2 or O2 or CO2 or H2O. Those are the chemical formulas for the things that we're actually working with or keeping track of. CH2, pardon? Okay. CH2, like the word version of that, which you don't need to know. This would be ethane. This would be oxygen.
we write that down.
I'm just trying to show you something here. This would be carbon dioxide. And this would be water. So if I were to use words to describe the chemical reaction, I would say ethane plus oxygen makes carbon dioxide and water. So these over here are my starting materials. And these are my ending materials. Okay, so in a chemical reaction, we have these chemical formulas that are present, okay? And I want you to be able to identify them. So the letters in a chemical reaction are going to be your chemical formulas. Questions about that? Can I go forward?
Yeah.
The entire chemical reaction is known as a chemical equation, okay? And it's some type of representation that uses symbols that allows us to see the stuff that we start with, so our starting materials, and our ending materials. Okay? And so the entire thing with all the numbers and the letters is called a chemical equation. Questions about that? May I go forward?
So products again are the starting material?
We're getting there. We're just
I'm putting the cart before the horse.
Yeah, a little bit. All right. Now, when you see numbers that are here, like this one and this one and this one and this one and this one, the lowercase numbers, the numbers appear to be hanging down. We call those subscripts. Like submarine goes under the water, right? Subscripts are letters or numbers that go below the line. So these are small numbers to the lower right of a symbol that represent the number of atoms of that element in the compound. So when I look at this particular compound right here, I see that I have, because of this, there are 2 carbons and 2 hydrogens and 2 oxygens in the formula and 2 oxygens in the formula. Now wait, how come this guy doesn't have a number behind it? Well, actually, yeah, it didn't want to. It actually didn't need it. If there's a letter that doesn't have a number behind it, we assume that it's a value of 1. So carbon dioxide is 1 carbon and 2 oxygens. Water is 2 hydrogens and 1 oxygen. Okay? So do you understand that? So those are your subscripts.
You forgot the period.
What period?
At the end of it.
It's not a full sentence. It's a fragment. Do you have a degree in English?
Oh,
Oh, okay. So moving on. Ready?
You didn't know what hour it was. And he's
Ready? All right. Now, hey, there's different things that are circled now. Now we have larger numbers that are circled there in front of the whole thing. We call those coefficients. Where have you heard the term coefficient before?
I heard coexist.
In what?
Cosine.
Which class? Math class,
I heard cosine.
right? So like if we have a math formula like 2x equals 4, right? This 2 is the coefficient. Same thing applies here. So I have 2 in front. So this would be a coefficient, and this would be a coefficient. That would be a coefficient. That would be a coefficient. Those represent the ratio of molecules of each substance involved in the chemical reaction. So I have really in reality, I have something that we could say a 2 to 5 to 4 to 2 ratio. It's a big ratio.
Wait, is there going to be a lot of math in this too now?
There shouldn't be. Can I go on now?
Not yet. I'm still writing the extra stuff.
So So can you do the coefficient subscript? Because there's numbers involved, the 2 and then the smaller 2.
Getting there.
Oh, is that next?
It's coming next.
See, I'm next.
Yeah, you're
You're using like Jedi mind tricks all over.
ready?
Yeah.
Okay, next. These are called your reactants. Okay, so the things that are always on the left side of the arrow, these guys right here are known as our reactants. They are, like I called them before, the starting materials.
Can you go back to coefficients?
I can. You were too busy clicking though.
Thought I wrote it in.
So these are called your starting materials. So, guys, ladies and gentlemen, every time you can have one thing as a reactant, you can have two things as a reactant, you can have three things as a reactant, okay? But those are always on the left side, okay? I needed to go back one, you said? Josh?
Yeah.
Okay. Can I go back now?
Yeah.
We good? Can I go forward?
Yeah.
Okay. Now, the last thing we're going to talk about are the ending materials. So these are the ending materials. Those are known as your products. Okay? Now, we need to tie a couple of things together here. Okay? So, what I'm going to do is I'm going to focus on this compound right here. Okay? And I'm going to go ahead and add a page here. There's a little space at the bottom of yours so you can use it. So the compound that that I'm going to focus on is 2 C2H, what is it?
H2
C2H2?
Yep.
Okay.
plus 5 oxygen.
I just want this one.
Okay.
Okay. Now, we said that this is a coefficient and that these are subscripts. If I need to determine the number of atoms total in a chemical formula, okay, I'm going to distribute. So if I'm going to identify the number of carbon atoms, I'm going to take the coefficient times the subscript, which will give me 2 times 2 equals 4 carbon atoms. Okay? If I want to identify the number of hydrogen atoms, I will distribute again to that subscript. So I will take 2 times 2 will equal 4 hydrogen atoms. So the coefficient, even though this is not something that you're asked to write down, I'm trying to help you because you will see this for homework. You distribute to the entire, to all of the subscripts. So another example, did everybody copy this down?
So you distribute to find the
No,
atoms.
the number of each atom.
And everyone remembers how to distribute during math class.
Nope. Just how you work in your ear.
So I'm going to do one more example. Can I go forward? Mr. Sussex, what was the water thing? What was like 5 waters, right?
Plus 5.
H2O?
2 H2Os.
Was
Are you
there
talking in the product?
in the
Yep, it was plus 2 H2O.
okay. So in this case, if I have 2,
Hey, we only have the.
I know what we only have, but I'm trying to show you some stuff to help you out for your homework.
Wait, this is our homework worksheet, yeah.
So in this case, hang on. So I have 2 H2Os. So if I want to determine the number of H's and the number of O's, In this case, I'm going to distribute the 2 from the coefficient to the subscript. So I'm going to take 2 times 2 will equal 4. So this is 4 atoms of hydrogen. But we've already discussed, pardon? I'm sorry, what? But I've already discussed that there happens to not be a coefficient or a subscript back here. So that means that there is so that means that there is going to be a 1 here. So when I distribute this, okay, so when I distribute this to nothing, it's going to be 2 times 1 equals 2. No subscript means 1. Does that make sense? So far, so good.
That makes sense too. Josh, that makes sense?
Okay. So I just added this statement, no subscript means 1. Okay, next, we are going to skip ahead. So here's the deal. You ready? Can I be done? Can I stop this now? Did everybody finish copying?
Yep.
Okay, stop.